So in this video we are going to prove or just visualize by integration that when a when a square is inscribed in a circle, what is the area of the lateral parts? Okay, we are going to find this area which I'm marking right here. So how to do it? So one geometric ways you can always do if the radius of the circle is a. So by geometrically it is also a. Pythagoras theorem, this will be a square plus a square is equal to this. We can name it as b square. So which gives us b is equal to square root of a. So by which we can say that area of the parts which are labeled is just by a square minus square root of 2a whole square, which gives us pi minus 2a square. Sorry, pi minus 2 times a square, right? So how are we going to prove this by integration? So just let us take the circle and then mark coordinates points. This is minus 0 comma minus a, 0 comma a comma 0, and this is minus a comma 0, and this is 0 comma 0. Now we're going to draw the circle, a square in it. Now this is also square. Now I will take a quarter of circle and perform my integration and find this area and multiply that area by 4 so I can get the whole circle. So it's easier to do this way. So, and one more thing, I'm going to perform the integration using polar coordinates. So that would be helpful. So we visualize how integration is done in polar coordinates. So let's start. So let's start by this. So okay. So what is the equation of this line? Look carefully. So if I were to write the equation of a line, y minus y1 x2 minus y minus y1 is equal to m into x minus x1. This is just the equation of a circle. So here have x1 x2 and y1 y2. So if we get y minus y1, y minus 0 is equal to y2 is a, and y1 is 0, so you get a divided by x2 is 0, x1 is minus a, x1 is a, so you get 0 minus a, and then you have x minus a, which is pretty much is y is equal to a minus x, the equation of that line here. So as we found that the equation of this line is a minus x, so all we have to do is integrate it. What we have to integrate? So I told you to choose polar coordinates. So as in polar coordinates, as you can see, the radius r varies from our y line to the outer circle. It varies from here to here. So I can say r varies from y is equal to a minus x to r, or is equal to, so as you can see, you have to write the equation of a circle as x square plus y square is equal to a square. So it just varies from y is equal to under root a square minus x square. So I can pretty much say that our r varies from, so how can we write the equation for r? So we can say y is equal to a minus x. So in polar coordinates, r sine theta is equal to a minus r cos theta. So I get r is equal to a over sine of theta plus cos of theta. So we can just plug it in. So we have to choose the integral sign of r varying r, and r varies from this two. You can write x square plus y square is equal to a square sine square theta plus a square cos square theta, which leaves us r is equal to a. So we can just say that r varies from a over sine of theta plus cos of theta to a, and our pi varies on theta varies from 0 to pi over 2. So integral 0 to pi over 2, and r dr d theta, so which is just dx dy in the Cartesian coordinates. So if you have to integrate this, so first do it with respect to r. So let's write the limits here, a by sine theta plus cos theta to a. What is the integration of r dr? Which is just r square over 2. I'll just bring the 1 over 2 outside and just write r square here, which gives us half integral 0 to pi over 2 of a square minus a square over sine theta plus cos of theta whole square with respect to d theta. So we can then we can bring a square by 2 outside, then integration from 0 to pi over 2, 1 minus 1 over sine square plus cos square plus 2 sine theta into cos theta, which can be written as 1 plus 2 sine theta into cos of theta, and then can pretty much simplify it by saying 1 plus 2 sine theta cos theta. So 1 plus 2 sine theta cos theta minus 1, which just gives 2 sine theta cos theta over 1 plus 2 sine theta cos theta. So a square by 2 outside is d theta. So how to proceed further? So I'm thinking of multiplying 1 minus 2 sine theta cos theta, but that doesn't pretty much do anything. No, it just makes the integration complicated. Okay, so I actually have to think. So it's pretty much sine 2 theta, right? 1 plus sine 2 theta, and this is also sine 2 theta, and this is sine 2 theta. So I can multiply by 1. Just okay. In my previous video I made some mistake and I had to retake the video again from this point. So I made a mistake by I put a cos 2 theta in the denominator is actually cos square 2 theta. So I will now a square over 2 integral of 0 to pi over 2 sin 2 theta over cos square 2 theta, which is tan 2 theta into sin 2 theta. So I know that's pretty terrible. So I just put a substitution that cos 2 theta is equal to some t. So dt is equal to minus sin 2 theta into 2. Okay, sorry. Okay, correct. 2 minus 2 sin 2 theta d theta. So sin 2 theta d theta is just minus 1 over 2 dt. So minus 1 over 2 dt. So denominator just becomes what I can say cos square 2 theta just d square, and then I have this integrate from 0 to pi by 2. I can change the limits or put it as it is, but I think it's easier to change the limits and integrate. So cos of 0 is 1, and cos of 2 into pi over 2 is just minus 1, so it just leaves us with the we change the sign 1 to minus 1. So how did I do this? Because cos of 2 theta, which is we're putting as t when t is equal to theta is equal to pi over 2, t is just minus 1, when theta is equal to 0, t is just 1. So that's how I did. So if I want to, I can change the limits by moving this minus sign. So I can say minus 1 to plus 1, and I have minus of sine square 2 theta cos square 2, which is just tan square 2 theta, and it's better to write that second square 2 theta minus 1. Okay, then I have a square over 2. So you can see that this thing 1 over 2 of minus 1 over t, because integral of 1 over t square is minus 1 over t, because the differentiation of 1 over t is minus 1 over t square. So I can say that it's just minus 1 over t integrate minus 1 to n, substitute minus 1 to 1. So what is integral of second square 2 theta? So what is d by d theta of tan 2 theta? It is just 2 second square 2 theta, right? So what is the integration of 2 second square 2? It is just 1 over 2 tan theta, right? Integration of second square 2 theta is just 1 over 2 tan theta. So I can write 1 over 2 tan 2 theta minus what is the integration of d theta? Is just what is integration of minus 1 into theta? Is just theta. So I have evaluated from 0 to pi over 2. Okay, a square over 2 times what is this? 1 over 2 of minus 1 just minus 2. So actually minus, so I can take minus outside and just write 1 minus of minus 1. This is just 2. Okay, 2. Then cancel out this 2. 6 this is only minus 1. Okay. Just below here 1 over minus 1 minus 1 over 1, everything is same. So I can just write minus half tan 2 theta, half tan pi. What is half tan pi? 0, right? Now what is half tan 0? Half tan 0 is also 0. So I got minus of what is integration of theta? Oh no, I have integration of d theta. So I got theta, I had 0 to pi over 2. This is just minus of 0 minus of pi over 2 minus of 0. Well, that's pretty much bad. Okay, right. So what I got a square over 2, and this is pi over 2, which is just minus plus pi over 2 and minus 1. So what is that? A square by 2 pi minus 2 by 2, right? A square by 4 times pi minus 2. And this, remember, this result is for the single quarter. If we have single quarter, which we have chosen to integrate that, find the area of sorry, not this, to find this is the area of this part, right? So this is the area of this part. So to find the total area, to find this total area, all the parts included, I just have to multiply by 4, right? Because 1, 2, 3, 4 are 4. So it's just 4 times pi over a square times pi minus 2. This gives us there's a square. It's just a square by 4, a square by 4. This leaves us with a square times pi minus 2, which we got previously by geometrically subtracting the area of circle, the area of the square from the area of circle. That's pretty much nice.